Hello, welcome to Convergent Dialogues. This is Xavier Bonilla. On this episode, I am very excited and honored to have the wonderful David Quammen on the podcast. David is an American science writer, and he has written many books, and he has written for many outlets such as The New Yorker, Harper's Magazine, The Atlantic, National Geographic, among many other magazines. He is the author of 17 books, including The Song of the Dodo, Spillover, The Tangled Tree, and the latest, Breathless, The Scientific Race to Defeat a Deadly Virus, which is what we talk about in this conversation. We start the conversation by talking about what were the signs of a pandemic. So we mentioned some of his earlier work in Spillover, the book Spillover, and which was written in 2012 or 2013, and how it really talks about pandemics, and it talks about things such as Ebola and the original SARS. And so it was very interesting talking about that. And, he had been writing about this decades ago, and now here we are with a global pandemic. And so what was it that was missed? And so we talk about that in the beginning. We talk about SARS in 2003. And, it's in the same family as SARS-CoV-2, but it's, how do we understand the initial SARS, how it wasn't a global pandemic, how we kind of dodged a bullet, and, what are some of the things that are similar with this pandemic. We talk about the two schools of thought on the origins of COVID, and how they originate, and some of the controversy around that. We also talk about the two lineages, A and B, and the variants, and then potential for future variants. We talk about the 4 types of magic that he describes, such as in herd immunity, drug therapies, vaccines, etc. We briefly touch on gain of function research, which was politicized earlier this year. And we talk about how are we prepared for future pandemics and what that looks like. I have not spent too much time sort of intentionally talking about all things COVID related. 2 reasons for that. One of them is there's just a lot of noise about it, and I don't want to contribute to any noise. I don't want to just kind of be reactionary and, what's the flavor of the week kind of thing. And so I want to talk with folks that are really smart, really, really sharp and clear on this, and are trying to give a very accurate but balanced view of things. And I definitely think David does that. Second reason is, we've been living this for 2.5 going on 3 years. And I just don't want to spend so much time talking about something that we're all experiencing. So, and sometimes you need some time away from these things to really see the impact. But to that end, if there's anybody I'm going to talk to about pandemics and zoonotic leaps and spillover, it would definitely be David. He's an absolute master at weaving together all of these things, all of these events that are happening, all of these, people that are involved, all of the science behind it in a very seamless way, in a very readable way, a very digestible way. And as I say in the conversation, this book, Breathless, this is stuff we just experienced, and yet it felt fresh and alive, and it felt like kind of the veil was pulled back a bit, and was like, oh wow, like this is what scientists were up to the past 2 years, and this is what they were trying to figure out, and here's what was happening. And he's just an absolute master at writing good science, and something that people can really just kind of get their teeth into. And I was very, very happy to talk to him. He's a wonderful person. He's obviously supremely talented. And so now I bring you David Quammen. I'm here with David Quammen. David, thank you so much for coming on the podcast. I'm very much looking forward to talking with you.
You're very welcome, Xavier. Good to be with you. Nice to talk with you.
Yeah, of course. So you've written a another wonderful book in your long list of wonderful books. This one is called Breathless: The Scientific Race to Defeat a Deadly Virus. And I know it's out everywhere now. So this is a fantastic book. This is great.
Thank you very much. Thank you.
Yeah. As some listeners may know, you've written a lot of fantastic books. You've written one on Ebola. You've written Spillover. You've written The Tangled Tree, which was really, really, really exceptional. So this is, again, really, really magnificent and I think super important. So tell listeners that may not know who you are, just kind of who you are, your background, kind of what you do currently, and why you wanted to write this book.
Sure. Well, the thumbnail, I guess, is I'm a science journalist and author, and I have written mostly nonfiction, although I began as a fiction writer 52 years ago. I published my first book, which was a novel. But, probably 40 or 35 years ago, I stopped being a fiction writer and became a nonfiction writer, focusing in particular, but not solely, on science and the natural world. I wrote a column on natural science for 15 years for one magazine, Outside Magazine. Worked for National Geographic magazine for 20 years, covering a lot of conservation stories, exploration stories. Got interested in emerging viruses about 22 years ago when I walked through Ebola habitat in Central Africa on an expedition, crazy wild cross Africa expedition that I covered for National Geographic. And while walking through Ebola habitat, I got intrigued by the mystery of the reservoir host of Ebola. Where is it that virus lives when it's not infecting humans? It has to live in a cellular creature of some sort, animal, plant, fungus, etc. Probably an animal, because the animal viruses are the ones that become human viruses, but we still don't know. And so with that mystery and the immediacy of it, as we walked through that jungle, knowing Ebola was there around us somewhere, I realized that the emergence of new viruses as human pathogens is all about ecology and evolutionary biology. And ecology and evolutionary biology had been my journalistic beat, so I started writing about the ecology and evolutionary biology of dangerous viruses. That led to a National Geographic article, then it led to the book Spillover, and then I carved the book Ebola, the little book on Ebola, out of Spillover. I also carved the 110 or so page section on the ecological origins of AIDS, of HIV, out of the book, and published that again separately as a book called The Chimp and the River, and then continued writing about molecular biology, The Tree of Life in the Tangled Tree. I really appreciated that you liked that book. The book was a little bit too heavy going for some people.
It's my favorite.
I tried very hard to make it a page turner and make it about humans, scientists, as well as scientific ideas. And then my publisher asked me to do a book on pandemic on this pandemic in early 2020, and I said yes.
Yeah, well, I'll say for listeners, when you read the book, it reads super. It almost reads like a story. At least this one. It almost has that kind of feel to it. You don't feel like you're reading a book about the natural world or the pandemic per se. It just feels like an account, and that. But also at the same time, it feels very rich with data and how you describe things, things that we've all kind of been through over the past 2.5-3 years, but it didn't feel, kind of like we were reading the newspaper again or reading the, news on our phone or whatever again. It felt fresh and new, and it was like, wow, and some of these things peeled behind, the curtain, and it's like, this is how we're sorting through things. So, yes, it's very, very good, and I'm glad you wrote it. So,
can I say something about that?
Yeah, please.
I think some of that, I'm very grateful to hear that, and I think some of that comes from the decision that I made when I was trying to figure out how to do a book about this pandemic that would be fresh and different from all the other books about the pandemic that were sure to come, and the fact that I couldn't do what I did with Spillover, which is, if I wanted to write about Ebola infecting gorillas, well, go to the Congo and walk through the forest with a scientists. Go to China and climb through caves with people sampling bats, looking for dangerous viruses. Couldn't do that. I spent the entire first 2 years in this room that you're looking at right now, Zooming like we're doing now. That was how I researched this book. So I decided to focus on the virus, make that my main character, but then focus also on the scientists who study this virus, and not just their professional views of it and their work on it, but also their lives as scientists and how this pandemic happened to them. So I pieced their stories together in order to tell the story of how the pandemic unfolded in the lives of scientists, the scientists who were closest to the virus.
Yeah, it's great because it does feel almost like various characters. And in the back of the book, I think there was 95 or 96 interviews that you did, and you kind of just give a paragraph for each one and just kind of, what they do and their specialty, which was also really, really nice. And so right before, I got the book, and before I started reading this, Breathless, I reread Spillover. So obviously I've read it before, and that was really strange to do that. Right? I read it when it came out, but it was strange to read it now after all the stuff we've been through the past couple of years. And then reading Breathless was like, oh man, like there were so many things we knew, there were so many things we could have done. So, we've known about deadly viruses for a long time. Many people have talked about, pandemics, and many people have been saying like, we need to be prepared for this. And you were talking about this, 10, 15 years ago. So I guess the first question I want to ask is, why do you think as a society, we haven't heeded the call to be more prepared for a global pandemic? Is something that you've thought about and written about, and all the signs were there.
Yeah, it is a conundrum. As you say, we knew so much. Scientists and the public health people knew so much. And therefore, any of us who were listening to them and talking with them also knew what this was going to look like to a considerable level of accuracy. And yet, we were so unprepared. People have asked me, what surprised you about this pandemic when it got going? And none of the science surprised me at all. New virus, coronavirus, coming probably out of an animal, probably in a wet market situation, the respiratory transmission, the fact that what made it most dangerous was transmission from asymptomatic cases. None of that was surprising. We knew all of that. All of that is in spillover, not because I could see the future, but because the scientists could see it. Right. So what surprised me was how unprepared we were. The degree to which national leaders, in particular our national leader, but not just, and the public health, the high-level public health people, with in many cases, but not all cases, hadn't absorbed the warnings, those abundant warnings of all sorts, and been prepared to contain this spillover before it became an epidemic in southern China and a pandemic around the world. I was in Tasmania researching a different book when this thing really got going. I went there February 6th or 7th of 2020. Before I went, I'll tell you this very quickly, in January of 2020, this rang a bell with me on January 13th when I saw the word coronaviruses in the reports that were coming out of the disease monitoring network. An outfit called ProMed Mail, a listserv thing that alerts all of its subscribers, 80,000 of us, to infectious disease events all over the world as quickly as they happen. A child gets sick in Vietnam and there's a post on ProMed Mail. We all get an email. Lumpy skin disease affects water buffaloes in Malaysia. We get an email about that. All these things. So you delete most of them. You get 10 of these or so a day, and you delete the ones that you're not interested in. I went back to my emails and I saw that I had deleted things about atypical pneumonia in Wuhan, China, until January 13th, 2020, when ProMed, for the first time that I saw, used the word coronavirus. Then that was the alarm bell for me. Coronavirus, this could be really serious. And about that time, an editor from the op-ed page of the New York Times emailed me and said, "Hey, Quammen, it's about time for you to do another op-ed for us. Well, do something for me on whatever you choose, maybe even, that new virus in Wuhan, China." And I said, "You bet I want to write an op-ed about that new virus in Wuhan, China." So I wrote an op-ed saying, "Folks, this could be it. This could be really, really serious. This could be the next pandemic." And that was published January 28, 2020. And then I got on a plane for Tasmania and disappeared and spent much of the next month in the bush of Tasmania with Tasmanian devil biologists for the other book that I was working on. But I started getting all these emails from around the world. "Hey, talk to us about this guy. Talk to us about this op-ed writer. Talk to us about this author of this book, Spillover, which we just discovered that was published, 8 years ago." So I started doing Zoom interviews and ABC Radio, Australian Broadcasting Corporation Radio, and spent half my time doing media on the subject of the pandemic, as it was turning out to be by that point. And then March 2nd, I flew home here to Bozeman, Montana, and went into this room and stayed here for 2 years. Got through, as you know from reading the book, as I said at the beginning, I got through 2020. After I got back from Australia, I got through 2020 on one tank of gas. I went nowhere.
I definitely put, very, 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 very minimal miles on my car as well, which was nice.
Yeah, it was nice for me too.
So I want to come to you talk a lot about the origins of SARS-CoV-2, but let's start.
Oh, but wait, Xavier, let me circle back and answer your question. I got about 3/4 of the way around the circle, but you asked, why were we so unprepared? Yes. Why was our reaction so terrible? So the reaction was probably terrible, at least in part, as public health people have said to me, and I quote them in the book, because of a failure of imagination. Failure of national leaders to imagine that the cost of being prepared for a pandemic that might or might not occur between now and the next election that you faced, the cost that would run to tens of billions of dollars to do things to really be prepared, failure of these people to imagine that cost could be much, much lower than the cost of actually responding to a pandemic. Instead of tens of billions of dollars, it would cost tens of trillions of dollars, 1,000 times different. Failure to imagine how bad it could be, and to imagine that the threat of pandemic was real and that it was going to come, even if the scientists couldn't tell you it will definitely come before your next election.
Yeah, I agree. I agree. I think it is. I think there's as a type of fear probably, but I agree with you on that framing, that it is a failure of imagination to say, like, what could all of this be and how should we be prepared? I think that, people, if it's not in front of you, it's like, well, maybe. And I think hopefully we've learned a few things now in terms of preparedness, but that will be determinate in the future, hopefully if that happens. So I want to talk about, before we get to the origins of this pandemic, let's briefly talk about SARS 2003. Right, so we're going to go back 20 years almost, because as you mentioned in the book, that was a really important progenitor to SARS-CoV-2. It's in the same family in terms of coronaviruses. So where did SARS 2003 originate? You mentioned, I think, the potentially being Chinese horseshoe bats, and then how did it spread? But more importantly, how is it contained? Right, because SARS 2003 did not be the global pandemic as it was. Right. I think it was in a few places, but how did that get contained? And then we can talk about, the current one.
Yeah. It was a really instructive story. It was a bullet that whistled past our ear. A couple of scientists that I talked to in the intervening years told me, well, that, we dodged a bullet. I I was doing a story for National Geographic on this subject, emerging viruses, in about 2006. And I met a guy who was deputy director of the part of the CDC, the American CDC, in charge of scary, dangerous emerging viruses. Ali Khan, wonderful guy, now dean of the School of Public Health at the University of Nebraska. And I had lunch with him after spending 2 days talking to all the scientists in his group. And he said, he's a kind of a jaunty guy, and he said, okay, Quammen, you've talked to all my scientists about these different emerging viruses. Which of these is your favorite? He's got this sort of gallows humor. He's a great guy with a big heart. He's been in all these dangerous situations, but he's still got this jaunty humor. Which of these is your favorite? And I said, I gave the entry-level answer. Ebola is pretty damn fascinating. And he said, I like Ebola as much as the next person, but for me, the dramatic one was SARS 2003. And I said, why? What was that? He said, that's the one where we dodged a bullet. That could have been really, really punishing to the human species. And he started talking about, coronavirus, respiratory transmission. Ebola doesn't have respiratory transmission. Yeah. And he said, we were lucky. We stopped it. And we stopped it at 8,000 cases and 800 deaths, partly because there was no asymptomatic transmission. People showed that they were really sick, and then they spread the virus. And a lot of people early on got infected because they didn't know, and died because they didn't know how serious that was, including a lot of healthcare people. The total on healthcare people in those 800 deaths was disproportionate, was high. But so how did it begin? Well, it began in late 2002. A couple people got sick in the Pearl River Delta of southern China, which is this big, concentrated, highly populous industrial area of the Pearl River that leads down to the sea near where Hong Kong, the island Hong Kong is. So the city of Shenzhen, somebody got sick. Fellow who was working in a restaurant. He had been dealing with wild animals that were butchered for food. And from one of those wild animals, he apparently picked up a virus. And probably it was a wild animal called a palm civet, which is a large cat-like thing that related to mongooses, but that is caught from the wild and also grown, raised as a domestic animal, although it's a wild species, for food. And they carry viruses. They carry coronaviruses. So it probably came from a palm civet, got into this guy, got into a few other people through restaurant situations. One of those people was a man, a doctor who worked in one of the hospitals that treated this guy. This doctor got infected. He went to Hong Kong by bus for a wedding. He checked into a hotel it was then called the Metropole Hotel, got room 911 on the 9th floor, and in the corridor or in the elevator, coughed, sneezed, maybe he threw up, we don't know, and contaminated either that elevator or that corridor or the 9th floor. And then people staying on the 9th floor got up, finished with their Hong Kong vacations, got on the planes from the Hong Kong airport, one lady flew to Toronto, flew to Bangkok, flew to Beijing, flew to Singapore, spreading this virus. And then it flamed up in those cities. Those cities that I just mentioned have strong governments and strong public health systems. And so it was contained. 8,000 cases, 774 fatalities. It was contained as soon as scientists recognized this is a dangerous coronavirus, respiratory transmission, got to stop it, got to contain it. They locked down in Singapore. I think, if I recall correctly, it got to Hanoi in Vietnam, or maybe it was Ho Chi Minh City. Strong government, strong public health, lock it down, stop it. They stopped it. And so those countries that had experienced that, Singapore, Canada, a few others, China itself, took it seriously. They knew that this was a serious warning. No cases to speak of in the U.S., no fatalities in the U.S. We missed it. We missed the warning. We missed the lesson of SARS-1.
Yeah, it's so wild how, we dodge a bullet and then, it's from the same family. It's crazy how it wreaked havoc on the world.
Yeah, and then the bullet from the same gun hits us between the eyes.
Yeah, that's right. Yeah.
I think of the different schools of thought on the origins as essentially two categories.
Okay.
The natural origins school of thought and the nefarious origins school of thought.
Okay.
The natural origin school of thought says that this is a wild virus that comes from a wild animal, probably ultimately a bat, possibly with recombination, some swapping of sections of the viral genome with other coronaviruses in recent years, either in bats or in some other animal, and then it spilled over, probably through an intermediate animal, probably in the Huanan seafood wholesale market. And natural selection was what shaped this virus. And it was naturally adapted to infect mammals, to infect actually a pretty wide range of mammals, including particularly humans. So that, and then there's the nefarious origin school of thought, which contains what I think of as roughly three different versions. First, that it was an engineered virus created in the lab for malicious purposes and intentionally released. Or it was a virus that was manipulated in the laboratory for scientific purposes, maybe ill-advised, quote, reckless scientific purposes, and then it accidentally leaked, got into humans, possibly through a lab accident. Or it was a natural virus from bats or some other animal that was brought into a lab and then simply leaked from that lab without having been manipulated. So I think of those as two schools of thought, and the nefarious origins school has essentially these three different subcategories. They're sub-hypotheses.
On the natural one, is that where the pangolin comes into play, potentially being an intermediary host there?
Possibly the intermediary host, yes. There are parts of this virus's genome that resemble parts of coronaviruses that have been found in pangolins. That could mean this virus went through pangolins. It doesn't necessarily mean that. It just means that coronaviruses have the capacity to jump from one kind of animal to another, not just from wild animals to humans, but from wild animal to wild animal. So a bat coronavirus could get into pangolins. A pangolin coronavirus could potentially get into bats. A pangolin coronavirus in bats could potentially recombine with a bat coronavirus, and so that part of a pangolin coronavirus genome would get spliced into the bat genome, the bat virus genome. But then it could spill over from that bat, for instance, into another kind of animal, like a raccoon dog, which is traded, or a civet that we were just talking about, or any of the other animals that are wild animals that were sold for food in the Huanan market. Bats, as far as we know, at least in 2019, were not sold for food in the Huanan market, but bats were part of the trade in wild animals for food, and they could have easily been at some point exposed to other animals such as raccoon dogs, bamboo rats, or civets in the course of the wild animal trade. And then some of those animals got up to the Huanan market carrying this virus and spilled it over into humans. That seems to me, and to the scientists whom I trust the most, as the most probable and most economical explanation for this. But we don't have final proof on that.
Sure.
And so the other hypotheses are still alive.
Yeah, so that's what I was going to ask, is that, it's obviously become very politicized here, and a lot of people have spent a lot of time talking about these origins, and many people will focus on maybe the more nefarious kind of origins. But you give two things here. You give an example of the Marburg virus, that it took over 40 years to figure out some of the origins. And while it might take us some time to find the closer to the origins of SARS-CoV-2, you also mentioned the work of Chan Ridley and some of their criticisms about the virus evolving naturally. So I guess the main question I have here, and you can detail those out if you want, but why is it just too simple for people to say, oh, there was a market, there was a coronavirus in one or two or multiple animals, it spilled over to humans? I mean, this happens. And then now we have a global pandemic. Is that just too simple of an answer for people to believe? And that's why maybe people go to these other kinds of, alternatives, or as viable as they may or may not be?
I think we have abundant evidence in history that people like history to be dramatic. People like conspiracy theories. People are still arguing about the John Kennedy assassination.
Yeah.
Because it was a complicated event. It was it was, flattening. I remember it. I was a 14-year-old school kid. I remember hearing the news that John Kennedy had been assassinated. And it was confusing and scary, and made more confusing and scary by things that happened. Was it this lone gunman? But then he was assassinated himself 2 days later on live TV. Did he make the shot of a lifetime, or were there people shooting from different, positions? So there was this mystery, because this breathtakingly significant, tragic event contains some unlikelihoods, some confusion, some mystery, and so people embraced conspiracy theories. Now, when I use that analogy, some of the nefarious origins people get miffed at me and get very sensitive, saying, "You calling us conspiracy theorists?" But I ask that question generally of some of them. Well, if you feel this was a conspiracy, or if you feel you embrace the nefarious origins explanation for this virus, I'm just curious, how do you feel about the John F. Kennedy assassination? And I'm genuinely curious, but they get very defensive and huffy about that. And yet some of them are saying, well, Tony Fauci conspired on February 1st, 2020, on a phone call with these scientists to suppress the idea that this virus had a couple of really peculiar elements in it that required more research for an evolutionary explanation. They conspired to cover that up. Okay, if your theory is that they conspired, then it's probably fair to call you a conspiracy theorist. So there's a lot of passion, and a lot of desire to believe that the nefarious origins of some sort. Why? Well, I think partly because it's more interesting, it's more dramatic, and because people are suspicious of authority. And it's not just people on the far right who believe in, who are election deniers and vaccine deniers. It's some other people too. You mentioned Alina Chan and Matt Ridley. Alina Chan is one of my sources. I interviewed her for this book. Matt Ridley happens to be a friend of mine. I've known him for years. We just disagree on certain things, but we have been not just science writer colleagues, but friends. And I hope we still are. And yet there is an eagerness to believe in these darker scenarios. And let me say one other thing about that. Some of these people, I'm not necessarily talking about Matt Ridley and Alina Chan, but some of these people, many of them that you encounter, for instance, on Twitter, approach this in what I consider the prosecutorial frame of mind. Their role is to be prosecutors. They're prosecuting Peter Daszak of EcoHealth Alliance. They're prosecuting Tony Fauci. They're arguing. Look at this. This could have happened. Here's this bit of circumstantial evidence. Here's this gap in the record. They're prosecuting this case against those scientists. I view my role as a juror.
Mm.
I'm listening to these arguments between the prosecutors and you know, if you want to call them defense attorneys, these people prosecuting and the people arguing against them. I've listened to those arguments very carefully for more than 2 years, and I feel like my role is to be a juror. What is true beyond a reasonable doubt?
Yeah, and I think it's important because, you know, when, you know, I talked to Nick Christakis here, and we talked about this a little bit, and he said, look, you know, these things are possible, these other alternatives. It's not completely out of the realm of possibility, but the main consensus and the overwhelming evidence shows that it probably was a zoonotic leap. There was some spillover, and
I agree with him.
And that's what we have now, right? We might get a whole mountain of data after the fact, and we have to adjust it. So kind of what you're saying, this kind of, how do we look at the evidence and make a decision here?
Yeah, right. And for instance, I agree totally with him. And for instance, if this virus, SARS-CoV-2, leaked from a laboratory, if you're going to prosecute that charge, this virus needs to be in a laboratory. And there is no evidence at all that this virus ever was in a laboratory, in Zhengli Shi's laboratory at the Wuhan Institute of Virology or anywhere else. There is no evidence that it was ever there. And Zhengli Shi, that scientist who runs that coronavirus lab, she was one of my sources also. I talked with her for 2 hours. She told me this virus was never in her laboratory. She told John Cohen, a senior writer for the journal Science, that it was never in her laboratory. She told Jane Chu, a Chinese journalist who publishes in English, that it was never in her laboratory. And maybe she was lying. Some people say she was lying when she talked to us. I don't think she was, but she makes her living by finding dangerous coronaviruses and warning the world about them. She makes her scientific career on that. She gets career advancement by publishing articles in major journals like Science, like Nature. Hey, here is a discovery of a dangerous virus or group of viruses living in bats in a cave in Yunnan province, China, and the world should be alert to these. That's how she scores points as a scientist. And she doesn't do it just for her career. I believe that she's genuinely interested in science, but she has incentive to publish a dangerous new virus as fast as she can.
Yeah.
But she never published this virus, and she says, and it's logical to believe her, that the reason she didn't is because she never had it.
Yeah, I mean, I think you're right. I think that there's, you know, I think if we're trying to be open to things and saying, okay, how do we see this, and this is what is all the pieces are sticking together here, we'll stick with that, and then it has to become, you know, preponderance of evidence, you know, to do it in any other way. I want to talk briefly about the lineages. So kind of moving ahead here. So when in this part of the book, I was remembering, I was like, oh yeah, I remember hearing about it. You know, this variant in the UK and in Brazil and India and all this. I was very reminded of reading that as it was happening. So there's these two lineages. Tell me if I'm wrong here. There's A and B, and actually B is the dominant one that we still get all of these subvariants of now, and that was what the Omicron was and all the whatever the most recent one is. So maybe just kind of give us, you know, just march us through kind of, you know, A and B, and then how we get all the way up to where we're at now and all the various places where it was mutating.
Right. So from the very beginning, from the earliest sampling in the city of Wuhan, like the first 41 cases of people got sick, and then they were sampled, tested for this virus, and then many of their genomes were sequenced. So when you sequence the genome, then you can create a family tree. You know all about this because you've suffered the fate of reading my book, The Tangled Tree, which goes on and on.
It's a nice compliment, though. I was remembering this stuff. It's a nice compliment.
Oh, I love it. I love it, Xavier. I love it. But so you sequence the genomes, and then you can build family trees. So what they found was, from the very beginning, there are two major limbs on this family tree. Mm-hmm. There's limb A and limb B. And that was seen in some of the very earliest cases. There was a distinction between the two of them. And then limb B essentially grows into a vast tree. Limb B is the one that gets the most nourishment, and grows and gets transmitted around the world. Becomes the dominant strain in Wuhan, but then it's also the strain that gets on airplanes for Milan and Bangkok and New York. So that's the one that spreads itself across the world. And that's why a lot of these variants and subvariants have a B in their code numbers, although now we know them by Greek letters like Alpha and Omicron.
Mm-hmm. Is A still out there?
Yeah, well, I think so. As far as I know, you don't hear very much about it, but yes, I think A is probably still out there. And this is, this is similar to what happened with AIDS, with HIV. The pandemic strain of HIV is just one limb off of a tree, HIV-1 group M, right? That, it comes from a spillover from a chimpanzee into a human in the southeastern corner of Cameroon back around 1908, spread across the world, HIV-1 group M. So in this case, it was lineage B spread around the world, and then diverged because it was capable of, it was constantly mutating, generating change, the raw material of natural selection. And some of those changes were proved to be beneficial, adaptive in certain circumstances. And so it became better and better adapted to humans as time went on. And we had these variants that took on these names. And one of the stories, part of the story that I tell in the book, as you know, is that Britain, the United Kingdom, contained a number of scientists who were particularly important, heroically important, in figuring out how to trace these different lineages and variants and create family trees. And they realized that to do that, you had to sequence. You had to be taking samples from people, not just testing them to say, okay, this person is COVID positive or COVID negative, but then taking the sample and sequencing the genome of that particular sample. There was a woman named Sharon Peacock. Wonderful character, wonderful story. I love telling her story in the book. She came from nowhere. She came from essentially a working class background. They didn't want to let her to go to college. She was going to be a shop clerk. And then she talked her way into getting trained as a dental nurse. And then she became a medical nurse. And then she became a doctor. And then she got a PhD in microbiology. And then she became one of the most important microbiologists in Britain because she was tough and intellectually hungry. I love her story. And she was the one who said early in 2020, we've got to create a consortium of labs, academic labs, private labs, government labs, to be sequencing this virus and getting as many looks at the evolutionary divergence of this thing as we can. And she worked with other people. She talked the government into giving her 20 million pounds to create this consortium. And so she and the people who were part of that consortium, I tell their stories in this book about how they started using sequenced samples to track the divergence and evolution of this into new variants, including the Alpha variant, the very first that came out of southeastern England and spread up into London and was spreading out and was coming to dominate the outbreak in Great Britain. And that became called the Alpha variant. And some of those, two of the people were these graduate students, these two young women in Edinburgh, working in the lab of a guy named Andrew Rambeau. And those two young women, Verity Hill and Anya O'Toole, said, okay, we'll put aside our PhD dissertation work, and we'll work on figuring out ways to place these different genomes of the virus on a family tree so that we can make sense of them. We can see where they're going and which ones are becoming dominant. And I loved telling their stories in the book.
Yeah, and listeners will get a sense that that's what you do. You tell a story, you put it in a contextual frame of a person and how they're trying to figure this out and how to figure out this mystery, and it makes for understanding it in, I think, that kind of that fresh way, in a really important way. So I want to get to the next bit, but there are going to be more variants, obviously, whether it's of the B lineage or maybe even others. But I guess, is there a certain point where, I don't want to compare too much because it's different, but much like with SARS, it was contained and we don't really see it anymore, I guess, right? So is there going to be a point where we just don't have variants anymore? Or is it just always going to be in the world, and it's just always going to be maybe more subdued or less harmful or things like that for most people? Where do you think does it just kind of fizzle out? What is your idea of this?
Right. Okay. Well, I need to make my usual disclaimer, which is that I'm not a virologist.
Sure.
I'm a science writer who follows virologists, listens to them.
Mm-hmm.
And what they say persuasively to me is we're never going to be rid of this virus. Almost certainly. You can never say never. But
sure.
Almost certainly we will never get rid of this virus from the human population. And even if we did clear it from the human population, we've got so many other kinds of animals around us now who are also infected with it that we would probably get reinfected by them. 40% of the white-tailed deer in Iowa or so are carrying this virus now.
Wow.
Crazy.
Yeah.
Crazy. So this virus now has an existence in wild animals almost independent of its existence in humans. And so we can always be reinfected by them. But so we're not going to probably ever be rid of it. Are we ever going to have it under control? Well, probably not, because it is so capable of evolving.
Yeah.
It is so capable of innovating in ingenious ways to get around our defenses, our natural immune system, and our vaccines and our antivirals. Tony Fauci told me this is a really nefarious and insidious virus, and described to me during our conversation about what I'm just saying is that this virus doesn't care how many people it kills. That's not important to us. I'm speaking as though it were, a personal entity, anthropomorphizing. But we know that it is a creature that is subject to Darwinian evolutionary imperatives. And those three imperatives are: make as many copies of yourself as possible, make as many babies, generate as many offspring as you can, expand yourself in geographical space, colonize habitat wherever you can, and extend yourself in time. Don't go extinct. Remain in existence. So that's all this virus is trying to do.
Yeah.
If it kills 1 in 100 people or 1 in 10 people, it doesn't matter as long as it still transmits on to the next victim. And so the question of whether it will evolve toward being less virulent, less pathogenic, has to think about evolutionary theory. You can't answer that question unless you realize that evolutionary theory is in play here. And evolutionary Darwinian imperatives say that there is no inevitability that it will evolve to be less harmful, unless somehow that increases its success in transmitting to other humans. So 40 years from now, we may be vaccinating kids. Probably we'll be vaccinating kids against this virus, and kids who don't get vaccinated will be subject to being infected with this virus, and adults who haven't been vaccinated will be subject to being infected. And presumably there will be still adults and kids who aren't vaccinated, and they will be vulnerable to dying from this virus. We know kids generally don't die, but older adults do.
Yeah.
And those who are not vaccinated will probably still be dying of this virus. It's important to remember we've had a vaccine against measles since the 1960s. For more than 60 years, we've had a vaccine against measles. Thousands of kids still die each year from measles. Measles is much harder on kids than this virus is. But the point is that thousands of people who haven't been vaccinated still die of measles each year.
Yeah.
And that can easily be true of this virus in 40 years.
Yeah. This is very sobering thought to think about. And that goes to my next point, though, is we can kind of end kind of this bit of the conversation here and talk about kind of the more recent things, which is you talk about, it was very interesting the way you framed it, which is 4 kinds of magic in the book. I'll just list them here. One is wish it away. I think you spent a paragraph on that. Rightfully so. Second, herd immunity. That was much talked about, especially early on. And then you have drug therapies and vaccines. So I would want to spend most of the time here talking about the drug therapies, because there was a lot of, quite frankly, bullshit on some of how it was described with ivermectin and many of these other ones. So just kind of walk us through the 4 kinds of magic, and we can spend time on the last 2.
Okay. Well, as you said, the first one, wish it away. Donald Trump, what was his comment?
It's just going to go away.
It's going to go away.
It's like magic. Away. Yeah, like magic.
That was like I think in February of 2020.
That's right.
Yeah. And as I say in the book, that didn't happen. Second was herd immunity. And I do a very careful unpacking of the concept of herd immunity and the history of the concept of herd immunity. And it comes from livestock herds. It comes from veterinary and agricultural thinking in the early 20th century. And I won't go into all that, but the bottom line is that the idea of herd immunity is mostly applicable to when you have a closed herd. If you got 1,000 cows and they get infected with a disease, then at a certain point, enough of them will have been exposed to this virus or whatever it is, that either they'll be dead or they'll be recovered.
Right.
And if they're recovered, if you're lucky, they'll have immunity and they won't be reinfected again. That doesn't apply to this virus, as we know. But
no, it does not.
if it's a more stable virus, you get that.
Yeah.
But that also assumes that you're not bringing in new cows that are susceptible. So if it's a closed herd, at a certain point, you get a certain level of of immunity. The virus, the outbreak tends to die out because there aren't enough remaining susceptible individuals in that closed herd. We don't have any closed herds of humans on this planet, except all 8 billion of us. Take us as one herd.
Yeah.
So we don't reach herd immunity in that sense until enough of us have been exposed and have either died or recovered and become immune. Except we know this virus evolves so quickly that people who have recovered aren't immune. They get. I know people who have been infected twice. You probably know people who have been infected twice.
3 times. Yeah.
Yeah.
3.
Yeah. So this virus doesn't play that game.
No.
Then there's the antivirals, hydroxychloroquine, chloroquine, and hydroxychloroquine. Those were used for years as anti-malarial medicines. I took chloroquine when I would go to tropical malarial places in the 1980s.
Sure.
And it worked, but then it didn't work because the malarial parasite was able to evolve resistance to it. So they went on to other things. Also, chloroquine has side effects. I had some of those side effects myself. They didn't, cause me heart failure, but so chloroquine was problematic. People said, "Hey, let's throw it at this new virus, this coronavirus." Well, wait a minute. Malaria is not a virus. It's a completely different kind of critter, and it may not work, and there may be side effects. Then there was, as you said, there was bullshit sort of pseudoscientific support for it, and that president of ours, I can't remember his name, kind of a ding-a-ling. He thought it was great, but it wasn't great. And then there was ivermectin that had its period, and ivermectin is essentially an anti-worm veterinary disease. You give it to your dogs, you give it to your cows, you give it to your horses to clear them of worms. And occasionally you give, well, not more than occasionally, there are worm diseases all around the world that are very devastating to people. So the guys who invented ivermectin won a Nobel Prize because it was so useful to prevent and cure worm diseases in people. And again, I took the stuff when I was walking across the Congo. I mentioned that walk across the Congo. We took ivermectin out of an eyedropper. I think it was probably ivermectin that was made for horses. We took it anyway because we didn't want to get these worm diseases like filariasis, like elephantiasis, from getting bit by these flies in the Congo forest that were carrying those things. But as I say in the book, this, you can still buy it. You can still buy it for your horses, your goats, your dogs to cure them of worms. And it's a trusted and reliable anti-worm disease, but not made for viruses in humans. And again, as I say in the book, the claw hammer is a trusted and reliable tool among carpenters, but it's not recommended for dentistry.
But David, did you read that one study? Did you read that one study that says this? And I had a cousin of mine who, he didn't get the vaccine and he took ivermectin. He was fine in, 36. Did you hear about that? Like that's what's happening here.
That's exactly right. Yeah, that's right. That's exactly right.
And not to poke fun at people, but it is one of those things where, again, it does feel like these drugs have a use for certain things. I don't understand how that could be used for a novel virus that's continuing to mutate. And we understand that it doesn't have the same kind of functions. It might have some maybe ancillary effect, but it's not made for that.
Right. That's right. And it can have side effects. It can do worse than nothing. It can do harm. But you can always find somebody anecdotally who will tell you that, yeah, my brother-in-law took it and, he was playing basketball the next day. Right. Great.
And then the vaccines. So
and maybe, he was shooting 3-pointers better than he ever had.
Right.
So maybe you should take it for that. If the jump shot's not going in, maybe you should take ivermectin because my brother-in-law scored 21 points the day after he took it.
Right. Okay, so then we have vaccines, right? So we have the main ones, Pfizer and Moderna are the two big ones. There are other ones, of course. So we just kind of say, just briefly, just mRNA vaccines, just the kind of, thumbnail sketch of how they work and why they've been working and how we were able to get it so fast.
Yeah. So mRNA, messenger RNA, is an information molecule. It's not just a genomic molecule. There are genomes that are made of DNA, genomes that are made of RNA, like this virus. And RNA carries information into cells, and cells use it to make molecules. And that's how viruses get themselves replicated. They put their RNA into the machinery in cells, and they get themselves replicated. If you feed a cell a little piece of RNA, messenger RNA, you can get it to make a molecule. That's the ingenious, wonderful trick of messenger RNA vaccines. You design a molecule that looks enough like part of the virus that you want to defend against in the body. You design that molecule and you make a stable form of that molecule. And then you back engineer the RNA, the messenger RNA instructions for that molecule. And then you shoot it into a person's arm, it gets into a person's cells. Person's cells make that molecule and exude it. So now that molecule is floating around in their blood. The immune system sees it, starts creating antibodies and responses to that particular molecule and prepares the body. And then the virus shows up, and this virus is showing the same molecule on its exterior. So the immune system is ready, and it attacks the virus and suppresses it, knocks it out. It's a beautiful idea, and this is, of my 4 kinds of magic, this is the only one that is genuinely almost magical in its value.
Yeah, it's super surprising how we were able to have this and do this. One thing that people get kind of annoyed about is, well, why do we keep needing to get these boosters and all these things? And my view is that, well, you have a moving target, an ever evolving virus that keeps having all these subvariants, and the initial one is not going to hold for years and years and years and years. Is it that just that simple? Yeah.
Yes. Yeah. And it's called Darwinian natural selection. It's called evolution. Yeah. Right. Evolution 101. Right. if you're growing soybeans in Kansas mm-hmm. and they keep getting attacked by grasshoppers, right? Mm-hmm. You spray with some sort of a terrible poison that kills insects, and it kills 99% of the grasshoppers that are infecting your soybeans. And it doesn't kill the last 1% because that 1% happens to have certain mutations that make it resistant to this particular nasty poison you're putting on there. Mm. And what happens the next year? That 1% of grasshoppers with this super genome, they come back, you spray them again, they laugh, ha, mm-hmm. We don't care about that poison. We're resistant to it because of our genetic composition. You selected for us. You eliminated all of our competition. You left just us. And now, we're going to eat your field of soybeans. And pretty soon you've got a zillion grasshoppers eating that field of soybeans. That's exactly what this happens with this virus.
Mm. Yeah. Well, the last question. So I don't. It's a little bit in the weeds and probably not as essential unless you want to just briefly say something about it. Everyone politicized this whole gain of function research with Dr. Fauci, and there's a whole stuff in Congress. We don't have to necessarily touch on that if you don't want to. But just knowing that the last two last questions here is. All of this stuff was politicized, unfortunately, where it was mandates, masks, vaccines, testing, everything has been politicized, I think. And, maybe some people ask some really important questions about how much should we do this, or should we do this enough, or should we, not have kids go to school for that long? Some of this was fair, and a lot of it became conspiratorial. And to that end, and so part of this kind of gain of function research also was in there too. To that end, I guess, this was a kind of dress rehearsal for something worse potentially in the future, right? And so how do we take some of the lessons we learned on how we had a lot of failings in preparing for this and dealing with it, but then also some of the things we did okay, and how can that help us prepare for future pandemics? Okay.
Let me say something about gain of function research, and I won't go on forever, and then we'll go on to the second part there. Yeah. There is an important conversation, call it a debate in the scientific community about so-called gain of function research that takes, for instance, a virus in the laboratory and manipulates it either through passing it through a series of animals or changing its genome using genome editing tools, makes some changes and gives that virus a new capacity to do something that it wasn't able to do. Gaining function. Mm-hmm. And that's very controversial. It's done in the case of viruses, for instance, avian influenza. It's been done to find out if avian influenza, which is killing killing millions of birds around the world right now, if it evolved to be a pathogen that could infect humans and transmit among humans, what sort of mutations might that involve? Mm-hmm. What should we be watching for? And some people say, well, there's no way of predicting, but other people say, no, we can, if we do that and we see how it does that, how it might transmit among an animal model, for instance, among ferrets, which are frequently used as models for humans, then we learn something valuable that we can be watching for. Mm-hmm. That's a legitimate argument as to whether that sort of research is valuable or reckless. And that argument has been going on for a long time, but in particular since 2011, 2012, when there was some gain of function research done on avian influenza. So there are scientists on both sides of that argument that are smart and reasonable. And again, I talk with some of them in the book. David Quammen of Stanford is a critic based on that, and he's a very smart guy, and I respect him. But being against gain of function does not prove that this virus came from gain of function research. So that argument only overlaps the whole question of the origins of this virus a bit. It only overlaps if the immediate progenitor of this virus was in a laboratory somewhere and someone was doing gain of function research. So even if Zhengli Shi was doing gain of function research in Wuhan, or Ralph Barrick was doing gain of function research at the University of North Carolina in Chapel Hill, which By some arguments they were, and by some arguments they weren't. Mm-hmm. If this virus was not in their lab, the gain of function argument has nothing to do with the origins of this virus. Okay, so where are we going to be prepared next time? Are we going to learn lessons from this? Yeah. I ask that question of a lot of my sources, as I show in the book, particularly in that section at the end, what I call credits, where I do a thumbnail portrait of each of my sources, and I put in things that didn't fit into the narrative structure of the book. And some of the best of those scientists said, "No, I'm going to be a negative on that. I'm pessimistic. I don't think we've learned squat. And we're going to make the same mistakes again," which is horrible because there's going to be another viral challenge like this one. It could be worse. Others say, "Oh, I refuse to be fatalistic about that. We have to have learned from this, and we do have to learn. We can't give up. We have to take the lessons from this horrible experience and use them to be better prepared for the next serious viral challenge, because it could conceivably be worse than this. It could be a coronavirus or an influenza that is as transmissible as this virus and has a higher case fatality rate. Could be transmitting from asymptomatic cases just like this virus, could be evolving new variants like Omicron, like this virus, and yet it could, just by happenstance, have a 10% or a 20% case fatality rate instead of a 1% case fatality rate. So instead of having 6 million people dead after 2.5 years, we could have 60 million people dead. It's possible, but it's not inevitable, because we know what we can do. We can watch for these spillovers and surveil the places where they are likely to occur and constrain them, contain them, and stop them. We can do that. We have the knowledge and we have the tools to do that. We just need the political will, and back to the failure of imagination. We need success of imagination to prepare us for what needs to be done.
Yeah, no, I wholeheartedly agree. The book is called Breathless: The Scientific Race to Defeat a Deadly Virus. It's out everywhere, and it's absolutely brilliant. It's super readable. I really couldn't put it down, and one of the most important books I've read this year. Where can people find you and all of your work?
Well, at your local bookstore, and my website is easy to find. davidquammen.com. There's more information about me there. But the best way to find me now and find what I'm saying and thinking is to get a hold of Breathless, I guess.
Yeah, no, it's great. David, thank you so much for coming on the podcast and talking with me about this.
Thank you so much. It's a good substantive conversation. I really appreciate it. You made it easy. We touched things that I care about. Nice to talk with you, sir.
Yes, nice to talk with you as well. Thank you.